Okay, and hello, welcome to the next video where we look at circles and their relationship in the subtopic of simultaneous equations, which you've seen before and we'll look at again, and I'm sure you'll see some common themes when we do simultaneous equations in year 12. So let's get straight into it. This is the worksheet from the workbook. So obviously a circle can intersect with different lines and curves. For the purpose of year 12, you just need to concern yourself with them intersecting with a straight line. So a circle can intersect with a straight line twice through two distinct points, once, and it will just touch at that point, at which point we'll call that line tangent, or it won't intersect at all. These points of intersection, if they exist, can be found using simultaneous equations. We can then use a discriminant to find out how many points of intersection. And I'm sure if you sort of think about this, the discriminant, anything that we can apply discriminant, there's always three cases, 2, 1, 0. Okay, so we're going to do an example together, and this is the side of circles as a subtopic which some students find quite difficult. Okay, so we're going to do this example quite slowly, understand exactly where the discriminant could be used, and how can we then do simultaneous equations to find points of intersection. So we've got this line, y equals x minus 1, and we've got this circle equation, x squared plus y squared, etc. Show that the x coordinate of the points of intersection of L and C satisfy this, hence find the coordinates of the points of intersection and state the geometrical relationship between the line and circle. Okay, so let's look at the first thing. Show that the x coordinates of the point of intersection of the circle and the line satisfy this equation. Now what that means in A level is you just need to show, using some algebra, that when you do simultaneous equations between L and C, and that's how you find points of intersection, that we get to this stage here. So let's think, we got from there to there, from this line to this line. The y letter has suddenly disappeared. The y must have been replaced with something, and the only thing that you could replace the y with is the equation of the line. So let's do that then. Let's replace y in the equation with x minus 1. Okay. Expand the brackets. So you've got x squared plus x squared, which is 2x squared, minus 2x plus 2x, which is 0x, plus 8x, and then you got 1 minus 2, which is minus 1, plus 9, which is plus 8. Now, to get to this stage, I have to divide through everything here by 2. Okay, so I've shown that the x coordinates of the points and sections do eventually get to this line. So I've shown that by doing simultaneous equations I'll get to this line. Now to find the x coordinates of the points and section, I'm going to solve this. So if you solve this, it's not too difficult, you get x equals minus 2. Okay, which shows that there's one point of intersection. And therefore, if x equals minus 2, then if I use my substitution from above, y is equal to minus 3. Okay. Now, what I need to sort of figure out from here is what the geometrical relationship between the line and the circle would be. And what I need to do in order to find that out is to apply the discriminant. And this is where some students struggle. Where do we apply the discriminant? You don't apply the discriminant on the circle equation given to you, nor do you apply it on the line equation. You'll apply the discriminant on the middle working this quadratic in x. You can only apply discriminant on an x quadratic. So let's apply discriminant here. A is 1, B is 4, C is 4, B squared minus 4AC, 4 squared minus 4 times 1 times 4, 4 squared 16 minus 16, which equals 0. Discriminant is equal to 0, and we've got one point of intersection. Therefore, the geometrical relationship between the line and the circle is such that we have a tangent. The line forms a tangent to the circle. Okay, the discriminant proves it, the mathematics proves it. Okay, so normally when you have simultaneous equations between a line and a circle, when you get to the quadratic in x, you can apply discriminant to just see what kind of geometrical relationship we have, and then if it does solve, then obviously that will back up the discriminant working. Okay, so that's how we do simultaneous equations with circles. So here are the practice questions, which I would recommend having a go at, and the stretch and challenge. Okay, and that is the end of the video.